Hey guys, welcome back to Geography World. For this video, we'll be looking at the Cape Geography Unit 1 2021 Paper 2. Stay tuned. I see the comments and requests and I will act on them. Please remember to follow Geography World channel on Instagram and Facebook using the link shown on the screen. Please remember to like, share with your friends and subscribe. For person wishing to contact me privately, you may email me at geographyworld100@gmail.com. The link will be posted below. Hi guys, welcome to Geography World. This video we're looking at question number 4. And question number 4, part A, said that we're to list 3 features of a tsunami that account for its destructive potential. Now, tsunamis are giant tidal waves that generated usually at destructive margin, especially by volcanic eruption or by submarine earthquakes. They can travel across oceans at speed of up to 600 kilometers per hour. As a tsunami approaches the land, its height increases and sometimes exceeds 15 meters. A tsunami is a geomorphic or geological natural disaster, and 3 features of a tsunami that account for destructive potential are: 1. The size of the tsunami. The larger the tsunami, the more destructive it is. The smaller the tsunami, the less effective it is. The distance. Number 2, the distance from the source to the coast. The closer to the coast the tsunami is, or the closer to the coast the source is of the tsunami, the greater the effect, while the further away from the coast the tsunami is, the less effective it is. The speed of the tsunami. The faster the speed, the more dangerous it will cause, or the more damages it will cause, while the slower the tsunami, the less damages it will cause. So you can talk about the size, the distance from the source to the coast, and the speed. Part B asks that we define each of the following terms as they relate to hazard. First one is forecast. Forecast is the process of using historical data to predict future events such as natural hazards. We have mitigation, and this is a sustained action taken to prevent or reduce the long-term risk to life and property as well as to minimize the economic impacts. And perception refers to how individuals or group of people view the hazard or risk, and it often depends upon their knowledge and experience of the event. Once you're able to answer all, 3 marks belong to you. Part C to the question gives us 2 images, and these were satellite images of Phuket on the Indian Ocean that were taken on the 31st of December 2004 after a tsunami. That's the B, and part image A was taken the 24th of December the same year before the tsunami. Now what we're to do is look at the 2 images and we're to state one, an area that was not impacted by the tsunami. Now, based on image A, we can see that it was all green, and then image B, you can see that a lot of the along the coastal areas now brown and not green. That's how you know that those areas were affected. So this was all green, which indicate that vegetation was there, but when you look here you realize that it's all brown. That means that it was damaged during the tsunami. So an area that was not impacted by the tsunami is 1, and if you look carefully, green, so it was not affected by the tsunami. Now we're to talk of an area that was impacted by the tsunami. 2, 3, and 4, they were impacted by the tsunami. 3 was hardly impacted, but it was also, but once you have 2 or 4 or 3, then you will get it correctly. But 3 was least affected for this question. So 2 and 4 would be a better answer. After identifying areas that were affected and not affected, we were asked part 2 to the question asked that using evidence from the image only, we are to calculate the distance of the maximum tsunami inundation on the coast of Phuket. And here to show a working, and the scale for the image is 1 centimeter equal 2.2 kilometers. Now, tsunami inundation is the horizontal inland penetration of waves from the coastline. Now, how you would go about doing this is first you have to go to the map. Since you have the paper in front of you, you would have to get a piece of paper or a piece of string, and you start measuring from the coast or from the coast to the area. Now, what you'd have to do is measure the area that has the longest. Horizontal is going across. You'd have to measure the area that has the longest horizontal damage. So when I was measuring, one could measure from this area to this area, and when I measured, I got 0.9 centimeters. So from this is the distance from the shore. Now I measured in centimeters. Now what I would have to do is basically convert what I have to centimeters. So we're gonna change the 2.2 centimeters, 2.2 kilometers, sorry, to centimeters. So 1 centimeter, remember, equal 2.2 kilometers. So we're converting that, and we're going to get 220,000 centimeters. Then you're going to multiply 0.9 centimeters times 220,000 centimeters, which gives you 198,000 centimeters, which means that the inundation rate is 198,000 centimeters. Or if you wanted to convert from centimeters to kilometers, it would be 1.9 kilometers. So all you're doing is measuring the greatest damage that you see on the map and multiplying it by the scale that is presented on the map. But because we have two different metric units, you have to convert to one. So your answer is either 198,000 centimeters or 1.98 kilometers, whichever unit you use. Part 3 to the question asks that we identify one limitation that relief organization may have experienced in responding to the tsunami that occurred along the coast. The limitations that relief organization may have faced are like: one, lack of resources such as supply, people, technology, and transportation. They may not have enough supply to have provided to persons within that region. For example, food, technology, transportation. Due to the tsunami, areas might have been cut off. They could not get to the coastal communities. They may have challenges with the delivery of relief aids to its intended recipients. They could have challenges accessing affected areas due to damages to infrastructures. There are several limitations that they could have faced. So once you're able to explain just one or identify just one, then one mark belongs to you. And as I said, there are several: lack of resources to basically help out, and resources in the sense of like supplies, people, technology, or transportation. Challenges to deliver the relief that they have. Challenges to get to the areas due to damages, and there are many other limitations. D asks that we explain how three human activities could increase vulnerability to coastal flooding. Now, three human activities that can increase vulnerability to coastal flooding are like deforestation. So, the removal of trees, it increases the speed of surface water flow, hence water reaches the coast faster. There is little to no infiltration, hence the coast is flooded quicker. Hence, you realize that the lag time is shorter. Urbanization. Now, urban areas include large forested areas coupled with paved slopes, large deforested areas coupled with paved surfaces, which basically prevents infiltration, and this increases surface water flow, hence flooding coastal areas quicker after a rainfall event. We have climate change. Due to human activities, there is increase in the greenhouse gases in the atmosphere, thus damaging the ozone layer. This leads to climate change, hence the glaciers in the polar region are melting and increasing water level in the ocean, thus flooding and reclaiming coastal lands. We have poor drainage. Some places have poor drainage system which quickly moves water towards coastal community causing flooding. These are just four human activities that basically help to cause coastal flooding. There are many others, but once we're able to explain any three, then 9 marks belong to you. Part E to the question asks that we explain two reasons why some tectonic plates subduct and others do not. Two reasons are one, the density and age of the plate. Now, if the heavier the plate, the more likely it will be to subduct. Oceanic plates are higher or heavier than continental plates, so they are more likely to subduct. The lighter the continental plate will float over the heavier oceanic plate. The older the plate, the denser it is. Older plates subduct while younger plates float over the older plates. So older plates are usually heavier, and usually these are oceanic crust. Um, the lighter the plate, these are usually continental plate, they tend to float. So oceanic plates, they are the ones that subduct. Then you can talk about the type of plate margin. Subduction only takes place at convergent plate margin, and oceanic crust are the ones that subduct. Once you were able to explain just two reasons why the tectonic plate subducts and others don't, a total of 8 marks should be yours, and a total of 30 marks should be yours once you were able to answer all questions.
We are at the end of this video. Thank you for watching, and please remember to like, share, subscribe, and turn on your post notification bell in order to receive more videos like these. Leave comments below suggesting topics that you would want me to present on. In the comment section below, comment the name of your school and the territory for a shout out in my next video. Until then, bye.